Hello guys, this is a continuation of the previous video. In the previous video, towards the end I told you I'm going to tell you about GCD and how GCD is calculated using recursion. Now before that, let's run this factorial program and check what the output is. Okay, let's run the factorial program, and as we calculated, factorial of 5 is 120. There you go. And let's say the factorial of 3 is 6. Now let's try one of the base cases. Factorial of 0 is 0. Now let's try factorial of 1. It becomes 1. Okay, so that was how factorial was calculated, and in this video I'm going to tell you how GCD is calculated using the concept of recursion. Let's comment this out, and let me uncomment this. Okay, so this is how GCD is calculated using recursion. Now I'm very sure all of you know how the GCD of two numbers is calculated, and let me explain the concept here. So for example, if I'm telling you to calculate the GCD of two numbers, let's say 10 and 5. So 10 can be written as 5 times 2, and let me comment this here, 5 times 2. 5 can be written as 5 times 1. So the GCD of these two numbers is 5, because GCD is the greatest common divisor, and the greatest common divisor of both 10 and 5 is 5. Now for example, if we said 15 and 5, it would be 15 can be expressed as 5 times 3, and then 5 can be expressed as 5 times 1. So what's the greatest common factor here? Okay, now first check what is common. Only 5 is common over here. So the greatest common factor of 15 and 5 is 5. So that is how the concept of GCD is, and that is how the GCD of two numbers is actually calculated. Now let's check this program, and as usual the main function gets executed first. We declare two numbers, and we ask the user to enter two numbers. We input those two numbers. Again guys, don't get confused with the scanf underscore s. This is just in Visual Studio, because Visual Studio says that scanf is not a safe function. So you use this just to prevent that error, or you can use the preprocessor macro #define. You can say CRT no warnings, and printf, the GCD of two numbers is, it goes to the function. It goes right here. Now this is the function my GCD. Here the two numbers, these are called the formal parameters, and we say if b is not, the second number is not equal to 0, and then we return b and then a modulus b. Now if you're not familiar with what modulus is and how it works, it basically returns the remainder of integer division. Now for example, if I say 10 modulo 5, so 10 modulo 5, so 10 divided by 5 is 2, and the remainder is 0. So 10 modulo 5 is actually 0. Now for example 20 modulo 10, for example, again when you divide 20 by 10, it's 2, and then the remainder is 0. Now 21 mod 10, now that will be 1, because the remainder of that operation is 1. So basically what you do is, if the second number is not equal to 0, you return, you call this function, and then you write the second number and a modulus b. Otherwise you just return the first number. So there's no point if the second number was 0. So now let's first execute this program and check for ourselves. As usual, 10 and 5, you can see the GCD of two numbers is 5, and then we saw for 15 and 5, the GCD of these two numbers is 5. So this is what happens. First the user enters the two numbers 15 and 5, and the second number, which is 5, is not equal to 0. So what does it return? It calculates the GCD of 5, and then what is a modulo b? 15 modulo 5 is 0.